All right, two questions to go, number 13 and 14. I think these were a little bit trickier. Now we have an ellipse with these two vertices. Again, I always start by finding the center of those, and right in the middle of 2 and 2 is pretty easy, but the middle of 8 and -2, add them together is 6, and divide by 2 is 3. So I know that this is an ellipse that opens out to the side, right? Because these are lined up horizontally with each other. So we are definitely an x minus 3 squared and a y minus 2 squared. Remember, it's a plus because all ellipses have that. And the distance from 3 to 8 is 5. So I know that this is 25 because remember, a is 5, which makes 8 squared 25. Now, this is where the problem became a little bit interesting, because if I call this b squared, then I need to make it go through this particular point, which is kind of interesting. So I'm just going to go ahead and plug it in and see what happens. And we're just going to leave this as b squared for the moment. So if I plug in the number 4, 4 minus 3 is 1. 1 squared over 25 is just 1/25. Plus, if we do this right here, -2/5 take away 2 is, let's see, let's call this 10/5. So this would be -12/5 squared is 144/25. But somehow the thing still has to be equal to 1. Now, I could put a b squared here, but I'd really like to find out what b squared happens to be. Now, in this particular instance, I'm going to clean it up a little teeny bit because, as it turns out, this 25 really belongs in the denominator. So I think I'll just do a quick little fraction buster. And let's multiply everything by 25b squared. Now, if I do, I would get b squared plus 144 is equal to 25b squared. Now, that's actually pretty nice because I can bring that across and say 144 is 24b squared. And if I were to divide both sides by 24, I would find out that b squared is 6. And that is, in fact, all I needed to do. And so if we would go into maybe something like Desmos, we could actually graph this and validate that it does, in fact, go through the coordinate 4, -2/5. And our final problem, number 14, a parabola with this vertex, an axis of symmetry. Now, that's something we haven't played with much. I've got 2, 5, and an axis of symmetry going this way at y equals 5. And I want it to go through the coordinate -1, which is to the left, 2, which is below. So the only way the graph can do that is if it's opening to the left in order to do that, because the axis of symmetry, which we haven't done much with, just goes right through the heart of it. So I know this is going to be one of those y minus k values equals 4p times x minus h. And then I don't know what this p value is, but I know it has to go through through -1, 2. So let's just see what happens. If I plug in 2 for y, 2 minus 5 is -3, squared is 9. And if I plug in -1 for x, I get -3. And so if I could divide both sides, I'd get 4p is -3. And believe it or not, I am now done with the review because we actually, it's weird that we do this in Conics, but we actually wanted to keep that 4p as it says. I can't make that thing go away. So 4p is -3, and so there is my answer, and that's going to be a nice little parabola that passes through the coordinate 1, -2 with the appropriate axis of symmetry. And that is it. That is the last video of the year. And it's been fun. I'll see you back in class.